Hi class, so in this video, we are going to discuss fixed end moments. No, so as you can see, I provided you a table, no, that contains formulas for fixed end moments, no, depending on the which type of loadings, no, act on it, no. Pero what if, no, you what if, no, wala dun yung type of loading na given, no, pero you still have to find the fixed end moments, no. So I'm going to teach you different methods. How are we going to determine them, no? So two of them, no, are the ones that we've already discussed on our previous lectures, no, yung method of consistent deformation and uh, three moment equations. Pero the third one, no, are just a rip off nung dalawa. Okay? So let's begin. So let's try to know first what are fixed end moments. No, so fixed end moments are the moments acting on fixed supports located at both sides of the beam. No, so consider this beam. No, and we have fixed support on the left and also fixed support on the right. And the the resisting moment that reacts on both sides of the beam, no, or both sides of the support, no, those are our fixed end moments. So determine the fixed end moments using all methods possible. No, so we have here a restrained beam, no, with length L, no, assume that this is in meters, no, and acted on a uniformly distributed load W, no, in kilonewton per meter, no. So we're only to find, no, the fixed end moment, no, instead of the usual uh, reactions, no, that uh, you need to find, no. And let's try using method of consistent deformations that we've already learned before, no. So uh, see, no, uh, technically this restrained beam is uh, third degree indeterminate, no. So normally kasi we only have in a statically determinate beam, no, we only have a vertical reaction, no, horizontal reaction, and a moment for a fixed beam, no, or a cantilever beam. Pero since we have another fixed support, no, there will be another three reactions, no. So uh, we so we know na the rest is history. Pero since in beams, no, we really don't consider much, no, the horizontal reactions, no. And nakikita nyo naman na most of the loads that are acting on the beam are just transverse loads, no, or uh, vertical loads, no. So we somehow take the horizontal reaction out of consideration. So therefore we only have two redundants here, no, and it's a matter of which redundant are we going to use, no. So since Ang hinahanap lang naman natin dito are the fixed end moments. We don't need the vertical reaction, no? We choose the moment at A and moment at B as our redundant, no? So I almost forgot to tell you, no, na we designate the moment at A as FEM A sub AB, no? So yung AB means, no, A going to B. Okay? And then FEMBA, no? Meaning fixed end moment, B going to A. Okay? No? So that is our that's what we're going to do. No? So if we decided to, if we choose, no, if we choose our moments as our redundant, no, this will become a simply supported beam, di ba? No? And then mawawala yung moment natin sa A, mawawala yung moment natin sa B. So therefore, simply supported na lang siya. Okay? And then we tend to determine, no, we retain the original load, and then we determine the slope at A, no, slope at A and slope at B due to the loads, no, in which we remove the redundants. Okay? So after removing the redundants, no, and just retaining the original load, we remove the load and then put all the redundants one by one. Okay? So maglalagay tayo dito ng at A, we're going to put a 1 unit moment, no? Let's say that is kilonewton meter, and then per kilonewton meter, no? So later on, we're going to multiply this by FEMAB. Then we know na if the beam is acted on by the moment at A, no, it will also result to slope, no, at A and at B at the same time, no? And then remove the moment at A, we put moment at B, no? Same thing will also happen, no? And we designate the slope due to the unit moment at A as FA1 and FB1. Okay? No? So FA1 and FB1. Next, yung moment naman sa right, unit moment on right, FA2 and then FB2. Okay? No? That is how are we going to designate all our moment. And then our compatibility equation now will become, no? So we just get the sum of all our slopes, no? So theta A1, no? Theta A1 plus FA1 multiplied by FEMAB, no? So due to this one, no, plus FA2 FEMBA due to this one naman is equal to 0. Okay, next, no, at on the all the slopes on the right naman, no, theta B1, no, this is theta B1, no, okay, theta B1 plus FB1 multiplied by FEMAB. No, this is the slope at B due to 1 kilonewton meter unit moment on the left plus FB2 times FEMBA unit moment on the right. And then we determine all the deflections that we need, no? Or rather, we determine all the slope that we need, no? So theta A1, FA1, A2, theta B1, FB1, and then FB2. Okay? No? So we will also designate our beams, no? Yung primary beam natin subjected to the original load, let this be your beam number 1. No? The primary beam naman subjected to unit moment on the left, no? Beam number 2. And then primary beam subjected to unit moment on the right, beam number 3. Okay? So we solve all the deflections that we need on beam number 1 first. Okay? So we already discussed this, no? So I'm not going to emphasize this further, no? So this is our moment diagram, no? Let's say we clamp it on the right. Okay? And then we are able to determine the slope at A by determining tangential deviation of B with respect to A, no? The tangential deviation of B with respect to A will become WL to the fourth over 24 EI. Pero ang theta A1 naman natin is equal to WL cube over 24 EI. Okay? No? We also determine change in slope, no? As the area from A to B. Change in slope is equal to 1, no? Theta AB is equal to WL cube over 12 EI. No? So direction wise, okay, theta AB, no? Uh, theta AB is positive. No? So also we know na yung theta B1 natin is also positive pero minus, no, yung theta A1 natin, no, technically negative. No? So theta B1 is equal to WL over 24 EI. So we now have theta A1 and theta B1. Next, we are going to determine now, no, all the slope, no, rather, no, on our remaining primary beams, no. So beam number 2, no, this is how will it look like, no. We have a 1 unit moment on the left, no. So if we decided to clamp it on the right, no, so we have a 1 kilonewton meter reaction here. And then we're going to have also negative 1 unit moment, no, which is constant. Okay? Our tangential deviation of B with respect to A, no, is equal to the area of the triangle multiplied by the centroid, no, starting from point B, no, and then area of the minus area of the rectangle, no, multiplied by the centroid from also from B. Now we have negative L squared, no, over 3EI. And our FA1 is equal to L over 3EI. Okay. Next, we have change in slope, no, from A to B, area of the triangle, no, minus area of the rectangle. Now we have negative L over 2EI. Negative L over 2EI is equal to theta B minus L over 3EI. And then we have negative L over 6EI as FB1. On beam number 3 naman, primary beam number 3, this is our moment diagram, no, since we are only to consider the reaction, no, on the left, no. And so ganyan yung itsura niyan. And then we compute for tangential deviation of B with respect to A, no. So will result to negative L squared over 6EI, no? And then our FA2 is equal to L over 6EI. No? So I would want you to try checking it, no? If we are to use method of consistent deformation, no? So EI theta AB is equal to, no, 1 half times 1 times L, no? That is equal to negative L over 2EI. Okay, theta AB, no, is equal to theta B minus theta A. Now, we have FB2 is equal to negative L over 3EI. No, so we have our value for deflections are now complete, no? So we compile it, no? We compile all our equations, no? We compile all our answers to the equations, no? Negative WL cube over 24 EI plus L over 3 EI, no? FEMAB plus L over 6 EI FEMBA is equal to 0, no? Plus WL squared over 24 EI, no? Minus, no? Plus negative L over 6 EI FEMAB, no? Minus L over 3 EI FEMBA is equal to 0. Okay? So we'll arrive at this equation and then we are able to get the answers, no? FEMAB is equal to WL squared over 12, no? One of them are negative, no? So that just indicates the direction of our moment. No? FEMBA is equal to WL squared over 12, no? So positive siya pareho, no? Because those are our assumed direction, no? So yan din yung lumabas na direction niya. Okay? So itong formula na to, they are written, no, on the tables that I provided, no, for fixed end moments, no. Okay? So we proceed with our next method, no. We proceed with the next method that we can use to determine fixed end moments. Okay, so we solve for another example, no? We have naman a concentrated load P, no? Acting at a distance A from the left and B from the right, no? With a length L, no? So what are the problems that we're solving, no? Are the typical fixed end moments, no, formula, no, depending on which type of loads that we are, which type of loadings that we have, no. So on this problem, we're now going to solve it using three moment equations, no. So we have two fixed supports, no, on the left and the right, no. So we do it this way: we extend, no, uh, we put an imaginary support, no, at an imaginary distance from the fixed support, no. So at A, no, and same at B, no. So we form, no, three moment equations at points A prime, no, point A and point B, and then we form another three moment equations at A, B, no, and B prime, no. So uh, let's do now. Let's form our equations now, no. So if we form an equation, three moment equation for A prime AB, no, assuming that EI is constant, MA times LA prime A over EI, no. So we don't have length for A prime and A, no. So plus 2F EMAB, no. So we designate the fixed end moment as FEMAB and FEMBA, no. Like just like the typical formulas that we use, no? Plus FEMAB times LA prime A over EI plus L over EI plus FEMBA, no, times L over EI again, no, plus 6 A prime A, no, times centroid A over L1 E1 I1 plus 6 AAB, area AB, times centroid B over L2 E2 I2, no, is equal to 6 times H1 over L1 plus H2 over L2. No? So we cancel out again, like what I said. we cancel out this one. We don't have, aside from the fact that we don't have moment at A prime, di ba? No, we also don't have length. So we cancel this out. We cancel out as well uh, L A prime A, and then we cancel out this one, no? So, and at the same time, no, this kasi wala tayo relative deflection, no? So we assume that all supports will remain at the same level. Okay, no? So we have now, no, what remains is matitira na lang dyan will be 2 FEMAB times L over EI plus FEMBA times L over EI plus 6 AB, area AB times B. No, this is first moment of area, no, with centroid measured from the right, no, assuming the span is a simply supported beam, no, over L EI is equal to 0. All the EIs will be cancelled, no? So that will be your equation 1. So for equation 2, three-moment equation for A, B prime. No? So FEMAB times L over EI plus 2 FEMBA times L over EI plus LBB prime, no, over EI plus MB times LBB prime over EI plus 6A AB A, no, centroid measured from the left over EIL plus 6L area BB prime B, no, over EIL is equal to 6 times H1 over L1 plus H2 over L2. So we cancel out, no? We don't have length BB prime, no? So wala rin tayong moment at B prime, and at the same time wala rin tayong length at BB prime. So wala tayong area, no, for BB prime, and then wala rin tayong relative deflection, no, at all supports, no? So what remains now will be FEMAB times L, no, kasi all the EIs will be cancelled, no? So plus 2 FEMBA, no, times L again plus 6 area A, no, centroid A, no, over L is equal to 0. No? So we compute now yung area AB multiplied by A, no, centroid from the left. No? So how are we going to compute that? No? We assume that the span is a simply supported beam. No? So this is your assume simply supported beam. We have the reactions PB over L, then PA over L. Just check it out, okay? And then this is the shear diagram, no, assuming that B is greater than A. And then this is our moment diagram, no, with moment equal to PAB over L. And then the area of AB with multiplied by the centroid with respect to A, or from the left, is equal to 1/2 times PAB over L times A times 2/3 of A plus 1/2 times PAB over L times B times A plus B over 3. No? So these are our centroids. No? If we measured it from the left, no, this is the 2/3. No? This is the 2/3. And then if on the other hand, we measure the full length of the smaller triangle, no, plus 1/3 of the larger triangle. And then if we decided to simplify it, where this will result to PA cubed B over 3L plus PA squared B squared over 2L plus PAB cubed over 6L. That is area AB multiplied by the centroid from the left. Area AB times centroid A. If ang centroid naman natin is from the other side, no? Area AB, B, that would be equal to 1/2 PAB over L times B times 2/3 B. So, dito naman yun. Okay? No? So, this one. Okay? Then going back, plus 1/2 times PAB over L times A times B plus A over 3. If we simplify that one, this will result to PAB cubed over 3L plus PA squared B squared over 2L plus PA cubed B over 6L. And then if we multiply each by 6 over L, no? Meron na tayong area AB with centroid times centroid with respect to A, and then area AB multiplied by centroid B. Okay? If we multiply each by 6 over L, magre-result siya into 2 PAB cubed over L squared plus 3PA squared B squared over L squared plus PA cubed B over L squared. If we remove the common factors, no, which is equal to PAB over L squared, no, this will become 2B squared plus 3AB times A squared plus A squared. No, ito na yan. Tinanggal natin yung PAB over L squared, so that will be the factors. If 6 area ABA over L, that will be equal to, no, 2PA cubed B over L squared plus 3PA squared B squared over L squared plus PAB cubed over L squared, no, is equal to PAB over L squared times 2A squared plus 3AB plus B squared. Okay? And then we put it on our 3-moment equations, yung mga nabuo nating equations. Ito na ang mangyayari dyan, no? So, 2 times FEMABL plus FEMBAL, no? Is equal to negative PAB over L squared times 2B squared plus 3AB squared. Okay? If we transfer the L on the other side, that will be equal to 2 FEMAB plus FEMBA is equal to negative PAB over L cube. No? So we factored this out, no? A plus B times A plus 2B. Okay? And we all know that A plus B is equal to the length. So therefore, no, maka-cancel out yung isang L natin, no? 2FEMAB plus FEMBA is equal to negative PA over L squared times L plus B. That will be your equation 1. And then same thing for our equation 2, FEMABL plus 2FEMBA times L is equal to negative PAB over L squared times 2A squared plus 3AB plus B squared. Okay? So ililipat natin ulit yung L sa kabila, no? To FEMAB plus 2FEMBA is equal to negative PAB over L cube times A plus B times 2A plus B. No? So yung A plus B natin is equal to the length, no? So magiging PAB negative PAB over L squared times L plus A. Okay. Next, we combine two equations. No? So we have two equations and two unknowns. No? So we combine the two of them. No? So we do process of elimination. No? So doing process of elimination, yung equation 2, we multiply it by negative 2. No? This will become negative 3 FEMBA is equal to 2 PAB over L squared times L plus A minus PAB over L squared times L plus B. We combine both of them, that will become, no? Okay? So, 2L plus 2A minus L minus B. Okay? 3, negative 3 FEMBA is equal to, no? PAB over L squared times L minus B plus 2A. Ang L minus B natin is equal to A. We combine it with 2A, that will become 3A. So we cancel all the 3, and this will become now FEMBA is equal to negative PA squared B over L squared. No? So you can check it on the tables for fixed end moments that I gave you. Okay, next, no? Lagay natin yung FEMBA natin on the other equation, no? 2 FEMAB minus PA squared B over L squared is equal to negative PAB over L squared times L plus B. No? 2 FEMAB, no, is equal to PA squared B over L squared, no, minus PAB over L squared times L plus B. No, so we combine both of them again. No, PAB over L squared times A minus L minus B. That will become PAB over L squared times negative 2B. No, so that 2 on the other side will cancel out. No, FEMAB is equal to negative PAB squared over L squared. No, so napansin nyo, they are both negative. No? So, ang sign convention natin when we use stream moment equation, ang pinapahiwatig niyan, no? They are both making the beam, no? Frown, no? Pinapasimangot niya yung beam natin, no? So, ang i-check nyo kapag nag-three moment equations kayo, when it comes to the sign convention, kung pinapangiti ba niya or pinapasimangot yung beam nyo, rather than kung clockwise ba siya or counterclockwise, no? Kasi 'di ba on the left side, no, ang magpapasimangot ng beam natin is counterclockwise, no? And on the right side, ang magpapasimangot ng beam natin ay clockwise, no? So that is consideration when it comes to sign convention ng uh, fixed end moments, no? Kapag gumamit tayo ng three moment equations. So, alam naman natin na if we keep on using method of consistent deformation, three moment equation in just solving for the fixed end moment, we know it will really take time, no? And solving for fixed end moment, no, is just a part of the next set of topics that we're going to discuss, no? So we are able to devise, no, a process. How are we going to solve for fixed end moments, no, even on the most complex type of loading, no? So we use integration, no? So yeah, no? Suppose suppose we have a restrained beam, no, length L, no, and with points A and B, no, on the support, no, subjected to any type of loading. Let's say this is a load, no, as a function of x, no, and ang x natin is measured from the left side, no, either the left side or the right side of the load, no. So ang x natin dito, no, is just measured from the edge of the load, no, hindi siya with respect to the beam. Okay? No? So gagamitin natin yung formula na na-describe natin kanina, no? And we are going to put, no? Maglalagay tayo ng imaginary load strip P, no? And that is equal to the area of W times dx. No? So this one. no? That is a load strip, no? And then with respect to the beam, no, from point A, no? From point A, no, ang magiging length niya is small a. And from point B, from the right, no, this will become your small b. Okay? No? So, fixed end moment AB, no, is equal to negative, no, integral of P, no, AB squared over L squared. And then that will be equal to negative integral of W dx, no, times AB squared over L squared from x1 to x2. FEMBA naman is equal to negative integral of P A squared B over squared, no, equal to negative integral of W dx A squared B over L squared, no? So yung negative value natin, yung negative sign natin dito, no, doesn't indicate hindi niya ini-indicate yung direction. Ang ini-indicate niya yung ano ang ginagawa niya sa beam natin, no? So negative here means, no, it's making the beam, no, form frown, no? Pinapangot niya yung beam natin. Okay? No? So pag pinapasimangot, ibig sabihin kapag measured from the left, no, that is counterclockwise. Pag on the right, that is clockwise. Okay, so let's solve an example. No? So this is another we're going to derive another formula, no? So that is uh, a triangular load, no? We don't have a load at point B, no? And we have W at point A, no? So we solve for the fixed end moment, no? And first, we determine kung we determine first kung ano yung equation niya, no? Kung ano yung equation niya, no, in terms of x. Okay? No? So, para ma-determine natin kung ano yung equation niya in terms of x, no, of course, ang gagawin muna natin, no, saan tayo magsusukat ng x, no? Dalawa lang ang pipiliin natin. Either from the left or from the right. No? So, we know na mas madaling mag-form ng equation kapag from the right tayo, no? So, we do ratio in proportion, no? W over L is equal to y over x. No? So yung y natin is equal to W over L x. This is now your equation in terms of x. Okay? No? So yung p naman natin will become, no, W over L times x multiplied by dx. Yung dx natin, that is the smallest, no, of load. Okay? No? So using the formula, no, ang A natin, no, is the distance from the left and yung B is the distance from the right. Dahil x na ang distance from the right natin, no, this is your B, ang A natin will become L minus x. So FEMAB is equal to the negative integral of PAB squared over L squared, no, equal to integral of W over L x dx times L minus x times x squared over L squared. Ang limit natin will be from 0 to L. So that will also be equal to negative W over L cube times integral of from 0 to L, no, ng L minus x times x cube dx. Okay? Will result to W over L cube times Lx cube minus x to the fourth dx. So, equal to negative W over L cube times Lx to the fourth over 4 minus x to the fifth over 5. From 0 to L, no, we substitute L in 0. No? So, pag sinubstitute natin yung 0, wala na yan. Negative W over L cube times L to the fifth over 4 minus L to the fifth over 5. That will become negative W times L to the fifth over L cubed times 20. No, ang FEMAB natin is equal to negative WL squared over 20. No? You can check that, no, from the table that I gave you. FEMBA naman is equal to the negative integral of PA squared B over L squared, no, equal to negative integral of W over L times X dx times L minus X squared times X over L squared. Okay? No, so that will become negative W over L cubed integral of X squared times L minus X squared dx. Simplify that this will become negative W over L cubed squared times integral of X squared times L squared minus 2LX plus X squared. We just expand this one. No? Then we multiply all by X squared. Will result in this one. And then we can now integrate them all. No? So negative W over L cubed times L squared X cubed over minus 2L x to the fourth over 4 plus x to the fifth over 5. No? From 0 to L, no? Substitute just the L, no? Mawawala na kapag sinubstitute yung 0. Negative W over L cubed times L to the fifth over 3 minus L to the fifth over 2 plus L to the fifth over 5. And if we combine them all, we result FEMBA will now become negative WL squared over 30. Okay? No? So, from the formula, no? So, dahil 1 over 20 is larger than 1 over 30, we know na yung mas malaki ang fixed end moment natin sa kaliwa compared sa kanan. Okay? No? So, that's all for this video, no? Yung everything that we've learned here, no, will be somewhat used on our next set of topics, no? So, for any questions, no, kindly leave your comments below or just message me on Blackboard, either Blackboard or any of my social media accounts, no? And then at the same time, no, if you want to be updated of the latest videos that I uploaded, no, kindly like and subscribe to this channel. Okay, so see you next video.